Hey guys, Dave here. Today we're taking apart some batteries that are proprietary batteries, and we're going to try and get them to work with an e-bike. So these batteries come in the package like so. These are marketed as 48 volt batteries, but they are 14S, I think 5P batteries. 14S is actually 52 volts. They are brand new batteries. They've never been used. They were used in robots, and I don't know why they're not being used anymore, but hey, we got them for a pretty good price, about $100, and we're gonna try and take them apart today. So now that we have the battery out of the packaging, we have 18 screws. I think these are T9 or T10. I only have a T9 Torx bit, so we're gonna work with that. Let's try and get this open. Okay, that's all 18 screws. Let's take this off. Okay, now we're down to the proprietary board. Now this is where things get a little bit interesting because I don't know how this logic board works at all. So what we're gonna do is we're going to, I wish I knew more about boards like this so I could actually get it to work. I don't know how to get this proprietary one working. So what I'm gonna do is I'm actually going to take this entirely out, and then I'm going to replace it with a 14S BMS of my own. So this BMS is coming out, we're putting in our own BMS, and we're going to make it work. And then we're going to actually take this logic board out. All right, I think I've got all the screws out. Let's try and, so it's kind of a little wiggly here. We can see it's soldered down. I don't know what this white stuff is. It's definitely not solder, but this is put down a little bit. Looks like we've got our NTP. I'm not sure what these connectors are called. These are the, I think it's temperature sensors right here. All these connectors right here. And that's got to be the logic for this right here, which is going to be like the button and all the configuration here. Let's figure out which one's positive and which one's negative. Okay, this side is positive, this side is negative. And these connectors right here look like they go to this back section right over here. So that's through the BMS. They're all connected over here. And so we need to disconnect all these sense wires over here. These are all the sense wires going through it. We're going to disconnect all the sense wires. We're going to disconnect these connections right here. I think the only way I'm going to get this off is if I cut this off. That's going to be a little rough. Okay. So we're all disconnected from the sense wires. We have all these connections taken apart. We obviously still can't get it off because it's going to be soldered here, 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 and here. So let's just get out our Dremel, start cutting. Here we go. Now obviously when you make cuts like this, you don't want to hit the cells sitting underneath it, but that seemed to work pretty well. We got the positive end disconnected, and we need to get the negative end disconnected. This one looks a little bit more robust. Ooh. Broke my blade. All right, new blade is in. Let's try this again. Okay, now we have both sides up. It's moving around a little bit. Now I need to figure out how in the world to get this off right here. I don't know what these are, but that's the positive and negative. Those are actually fully disconnected now. But it might actually be connected from the backside to here. This might be where it actually connects. I don't know. I'm gonna have to cut through this and cut through this. type of connection still holding it on. I'm just gonna try and rip it out now. Whoops. There we go. Look at that. There's nothing in these connections right here. So I was right. These connections just go straight down through to here. I can just cut these off. Okay. We are disassembled for the most part. Now, we have this BMS. We need to clean off these contacts to prepare it for the BMS, and then we're just going to be installing a battery management system. Just want to make sure this is going to fit. Oh, there we go. That's perfect. Yeah, we can just slip it right there. Toss this right here. Put the cover back on. Pack it a little bit. Should be pretty cool. So we got all the contacts cleaned. And the issue now is that these are pretty hard to solder. They seem to be some type of aluminum alloy. And I had to break out the big guns because, man, these things take a significant amount of heat to even do anything. So we're just going to put a little flux on these guys. So I'll show you what I mean. So that one's working actually pretty well. I'm getting some, it's sticking somewhere. I just barely finished soldering this whole section. So these were really hard to get some solder on. I think there's some type of aluminum alloy because I tried to spot weld it. That did not work well at all. So I just ended up putting solder on it. I used this big 200-watt solder gun that I had to put enough heat on there, and I was able to just sand it down really quick, and then immediately before the oxidation hit, put some solder on it. So they're on nice and tight now. So now I got to do, I'm not sure if I need to use this solder gun anymore for these tabs right here. I guess we'll find out. But we just need to put the BMS on, put all the BMS leads on, and then we're going to put the positive and negative terminals coming out here. We'll have the charge negative coming out here, and then we'll have our XT90 discharge connection and our XLR charge coming out of the top. So we're just going to put down some fish tape right here to protect the batteries from the BMS and the BMS from the batteries. The batteries are already wrapped. You can see this wrap on the battery. This is just a precautionary measure. I think it's fine as is, but we're just going to go one extra step just for funsies. Now that we have the insulating tape, let's just verify that all these connections are working properly. "41, 45, 48. Perfect. Everything's working properly. And thankfully, the BMS actually sits in between this, which is super handy. All right, we're actually getting really close to finishing this battery pack. We've got all of the solder joints connected. We've got the positive, the negative. Oh, I guess we don't have all of them. We still need to solder the negative side on these, but the positive's connected, so these are live. I didn't want to connect the negative side because that'll make everything live, and I want to do the connectors first. So we're going to put an XT90 for the discharge side, and then we're going to do an XLR for the charge side. And we're going to use 16 gauge wire for the charge, 12 gauge wire for the discharge. That's the plan. All right, we just did a test charge off screen. Everything is working properly the way it should be. Time to wrap this up. And the way we're going to do it is like this. We're essentially going to put everything under a coat of silicone. The negative terminals, get some silicone in here. We really want to make sure that these connections here get coated with silicone because we don't want these tiny little wires moving around and ever coming out. So these are going to get completely coated with silicone, especially where the solder ends and the connection begins. Now that we've got it all put together, we are going to seal it. Okay, so we've got the lid back on. We're just going to tighten these down. So that's it. Now we have a complete build, an 18 amp hour battery that's BMS protected. It has a 40 amp BMS It had a 100 amp fuse on this. This particular BMS can actually burst up to 3 times its rated continuous amperage. So it's rated for 40 amps continuous, can burst up to 120 amps for about a minute. And that's plenty of juice to get up to speed when you're on an e-bike. I think it's the right sized BMS for this particular build, and I'm really happy with how it turned out. Thanks for tuning in, thanks for watching, and I'll see you in the next one.